This is a CAD file that's relevant to Ansys, right? You have to export it into another format readable by ISIM CFD. So we will go here, File, Export, and then here, rather than .agdb, I will go for Parasolid text, right? And then I have to decide where I want to store it. I will go to this Advanced Thermodynamic Exercise, and I will call it anyway, whatever, burner case 1. Okay? And then I will export it. The moment you export it, leave this and launch ISIM CFD. Right? I will launch ISIM CFD Ansys. This is ISIM CFD. You see this one? Launch it. Right? Hopefully it will not crash.
What's the difference between these two formats?
This is a measure. This ISIM used to be a totally different company. It was bought by Ansys. And they adopted the measure for it. Right? Now, so I'm going to come here, File, Import Geometry. Import Geometry, and I will go to where? Parasolid. Right? This is denied. Forget about it. Let us go to where here it is. Okay, this is the case. I will click at it twice, and then I will say okay. Okay, let us see. Create a new project? Yes. Create a new project. So basically the burner has been imported here. That burner was imported in the new. Now this is just the curves, right? If you go to geometry here, and if you put points and surfaces, the whole geometrical entities will appear. You can look at it in this format. You can look at it in this format.
Wireframe and solid.
Yeah, in a frame or shaded there. Right. So this is our geometry is back here now. These are parts. It is called part 1 now. I'm gonna isolate. I'm gonna look at it as a wireframe first of all, like that. Now I'm gonna put everything off and put the points. Okay? Remember, this is if you put the curve, that is how it looks. Make it slightly smaller so that you can do it. Now I'm gonna right click here and say create part. Put off the curves, and I only want to isolate the points. I want to move them, call them points. And then take this cursor here and include all of them like that, and click in the center here. Okay, and then points has gone. Yeah, I'm going to put the curves, and I'm going to create another part called curves. CURVS.
So where did that points go?
They are stored in these points.
Okay.
Again, I'm going to take all this, surround it all with a block like that. Click in the center, and then the curves has gone. What is important to us guys is the surfaces, not leave part 1. The surfaces are very important to us, right? So these are the points and curves has been stored here, which I have put them off. If you put them on, they will appear, right? I mean, put the surfaces off, put the points on, they will appear to you. See, on and off. Do you see them? Put the curves on and off. You see the curves? You can change the color if the color you don't like it. You can change the color. Change color. Red or whatever. Black. Yeah. Right. So these are the curves. We store them here, and these are the points. If you put the points on here, the points here, you see? Points and curves. So we are not interested in neither the curves nor the points. We are interested in the surfaces, because the surfaces are where you put, right? Now, do you remember we said the eye will come from here, right? I will create another part, right? Click, if it is there, create a part file. I will call it inflow eye, where the flow of aya comes in, and then I will take this one and select exactly where the aya is. Right? You see, inflow aya. You see. Let me check the color because the color looks bogus here slightly. Right? You see the inflow aya. Put it on, and then again I have inflow fuel. Right? And inflow fuel. This is the one, right? Surrounding, right?
Yeah.
And then click OK, and then inflow fuel has been created. You see? Do you see? So that's those surfaces, right? Now the other most important part is the outflow. Outflow, where all the byproducts of combustion will come. If you want to be in a dynamic mode, press F9. F9 again, and this is the outflow, right? This is where, so the fuel comes from here. The air the fuel comes from here. The air comes from the center. They burn here, and they all go out with the outflow. So that is the outflow. Okay? These are the most important parts. If you want to be more creative, isolate all of them. Say this is side 1, side 1. Take it off. Where is side 1? Side 2. This one here. No, this is side 2 here. Take it off. Call that one top. This one here, call it the top. Take it off. Bottom. Take it off. Okay. We have side 1, side 2, side 3. This one here. Take it off. Right. Pipe 1.
Layer 1.
Pipe or layer 1, whatever. That one there. Pipe 1A. Pipe 1A. Pipe 1B. The next part here. So you can take them off. Pipe. And then pipe 2. Pipe 2A. Pipe 2B. Lower one. Take them off. Right. Inner shell. Call it inner shell. Right. Inner shell A. Inner shell B. Okay. Take them off.
What's the advantage of making so many?
More precise.
It tells you if you want. Okay, good question. What is the
be more
advantage of
creative.
this? Why am I dividing into it? If you want to give a specific surface different mesh, it helps you. It's better to isolate them. They call this connection.
Connection. Okay. This also goes.
Do you remember there was something called part? It disappeared because now everything is being taken from it. It was automatically removed. So now you have created parts. Everything has a name, right? Now, in order to connect it as one body, you have to create a body. Put the points on, right? And then come here. You see this function here? Create a body. Click on it. Body between 2 points. Take 2 diagonal points, far ends. So what I will select this point here. I will select this point here. I want 2 diagonal points. So if I select these points and I select these points, the body will be created here. Now the body connects all the geometry as make it one body to deal with as one body. Now here we are. We have finished the part 1 of the problem. Put the points off. Put the bodies off. We don't need them at the moment. Now we are coming to the mesh. Now we would like to divide this computational domain into small elements. So I'll come to the mesh here, and then there is a global setting here. The global setting gives you a scale of 1. If you put the maximum element is equal to 1 and and press on this, put on these displays and say apply, what you are seeing here, you see that large mesh point?
Yeah.
It is telling you that I'm going to divide this geometry by a mesh elements as large as that one, which is too large, isn't it? Leave the scale as 1, come and make this smaller, 0.1 or 0.01, divide it 100 times. 0.01 or 0.01 or point. If you say 0.01, say apply. Do you see what happened? It will tell you, oh, I'm going to reduce this to this size, which is too much. Now this is, it helps you to build sense about the element size. I don't want this, I will say 0.5. Oops, what have I done? I will say 0.5, apply. 0.5 looks too large, isn't it? It's too large. So I will go to 0.25, apply, it's too large. 2.2. 0.2 is slightly not bad. I want to create, let us call 0.15, 0.015. Not bad, huh? Do you agree with me?
How you know it's not?
How you know it's not bad? This is the computational domain. And this is the science you have. That is my personal judgment. It is absolutely a human judgment. Absolutely a human
The
judgment.
size of the mesh varies the analytical data.
Yeah, but I tell you something. This one here is reasonable for this geometry, but it's not reasonable for that geometry, for this connecting part. Do you remember? If you put anything off, if you put side 1, side 2, where is the connecting? See the connecting. If this element is okay for this large geometry, it's not okay for this geometry. Right? So the global one is basically what the global means what? It's going to mesh the whole geometry, all surfaces with elements as large as this one. But you know deep there, this could be adequate to this part, but it's not adequate to this part. What would you do? You will accept this, okay, as a global.
Okay.
Now you know the elements, you know the surfaces which need to have more finer mesh, right? So if you agree with me, the parts that you need, that is sensitive, that needs finer mesh are what? I could talk about the inflow of fuel, right?
Yeah.
And the inflow
Of air.
of air. And the connecting part. And even the, okay,
Even the pipes.
even the pipes, the smaller pipes. Okay? Even the smaller pipes. So I will select all these. You see this parameter here, surface mesh setup?
Yeah.
I will click on it and I will select all these meshes. In my opinion, the connection rod should be left slightly more different mesh. Where is it connecting? Take these elements alone. In fact, I will take all of the inflow air alone and give it fine mesh. Inflow air and inflow fuel. I will take these two. Guys who those who are chatting, okay, don't come to me and tell me I need help later on, please. Now I remember I gave that one is how much? 0.0 what? Do you remember?
0.115.
0.015. So how much do I give them? That 1.015. So shall I divide them by 4 or by 5? Divide them by 5, it becomes 0.003. A height ratio is basically okay. A height ratio means expanding from small to large. I will give it the factor of 1.1. That is to say, please increase the cells by a ratio of 1.1 while you are marching. And I will say apply. Okay? Now I'm going to go to these pipes alone as well. The pipes.
One more.
Yeah. And I'm going to select them and I will give them double this amount. I will make them 0.006 and 1.1 ratio applied, right? So I gave these the connecting rod. The connection, I will give it even smaller because it looks more smaller. I will give it 0.0015. A ratio of 1.1. And then I apply. What else have left? Even the outflow, give it a slightly better mesh. The outflow, give it a slightly better mesh. So, do you remember the largest one is how much?
0.015.
0.015.
Yeah.
0.015, right? So I'll give it 0.01 and 1.1. Now I have built a sense about my mesh, right? I'm gonna ask it to build a mesh, to compute the mesh. Let us see. You press here, and then tell it compute straight away.
Fingers crossed.
And then let us see. If it goes to million, stop it. If it gives you a decent mesh, okay, 3,000 mesh. That's not bad, in my opinion. Although you can improve on it. So I recommend for you to build another mesh. This is the standard mesh. I will give it to everyone to do his job. If you can do another mesh and give me a test with another mesh, that will add more speed to your report. That's all I can say. So this is the mesh, guys.
What exactly is being displayed by this mesh?
Okay, what is this display? Do you see? Okay, let us put it up and have a
Like
look
how
at it.
different is this from that what we made in?
Okay, what you are seeing here is that this geometry has been divided into small elements. Okay, you did automotive engineering now. Now these elements, what does this code does? It solves Navier-Stokes equations of motions. What does it do? That is part of your coursework. Is to build, is to understand what are Navier-Stokes equations, put them in their mathematical forms, and find out how they are solved using turbulence modeling. This is your first part of your report. This is the second part of your report, a case study, right? So basically, what it's telling you, the geometry has been divided into smaller elements, and then what the code does is solve all these Navier-Stokes equations in each element and give you an integrated solution to the combustion problem here. Now I have done all this. I am going to save it. File, save project as advanced thermodynamic exercise. Okay, Barner case 1.project. Okay. So you can look at it from all angles, yeah, because you have opened it. You can look at the mesh from all sides to see how okay or unokay it is. This is judgment. This is how to build your judgment on the right. You can see here the mesh is fine.
So what does this fine mesh like signify?
Okay. There are some areas. Why did I put fine mesh here?
Yeah, exactly. And why loose?
These are the areas of interest. These are the areas where the physical phenomenon is taking place, and you need to resolve it carefully.
Okay.
Coarse mesh will not give you good results. Having said so, it doesn't mean that very fine mesh will give you the result. It will give you the negative results. Read more about numerical methods. That is part of the coursework. I'm going to talk about it the moment we run the case. Right? I'm going to give you what you need to do, what you need to study, what you need to put in your report. So, fine mesh means you are resolving the flow carefully. Coarse mesh can give you some sort of solution, but not really.
Yeah, it's like you're even allowing the impurities to enter also.
Right? So we will see. That's why I encourage you to use two surfaces, two kind of meshes to compare between them. Fine mesh. The 1.1 ratio, you can see here, it is very small, and then it starts expanding, right? Increasing by 1.1. right? So this is the mesh. I have solved it. I have saved it. And I'm going to ask anyone to train himself on how to do the mesh. However, next week we will come. If you can't do the mesh, we're going to give you this standard mesh, and I will ask you to develop another mesh and compare and run 2 cases, if possible. If possible. Right? If possible.
Did you also include, like, choose the colors for each mesh, or did they come by default?
No. I mean, you can choose the colors.
But did you choose these?
No, I didn't choose any color. I choose some colors here. Some few colors I chose them. But if you can look at it in this format, and then you can see how the solid part was divided into what? Small. Remember, this is the solid part, isn't it? If you put the outer pipe.
So the color of the mesh depends on the color of the part you
It
select.
doesn't matter the color of the mesh. Forget about it. The color is just to give you a visual.
Differentiation.
What matters is the size. What matters is the size. What matters is the size. So the solid part only. Do you see that cut is left? Nothing there. So the fuel, the air will come from where?
From here.
From here. The fuel will come from here, and they all go to burn into the burner here.
Through the connector.
Yeah. They're connected here, and they will burn here. They will burn here. See? They will burn here. Now, assume I want to put this in my report, this image. Always span it, please. Make it as big as possible to span the whole. And then, do you see this camera here? Where is the camera? You see view? Where is it? No, it is hiding here. View, save a picture, and then I will name it mesh. Mesh. Mesh.
Where is the camera? Mesh 1.
Mesh 1. JPG, and where am I storing it? It is here. Save.
You didn't put any file name?
No, it is mesh 1.
Just
No, I just want to check where and then say OK. If you go to the directory, you will find it here.
Inside that, yeah.
So this is the photo you have just taken. You just put it in your report and say this is a photo of the mesh. So you will put 2 photos of the mesh. You can take different parts.
Different angles.
Yeah, I mean the more colorful pictures you put in the report, the more sweet it is. The more delicious. Yeah.
So we're actually getting the marks for the aesthetic.
Yeah. Right, so put it wireframe. That will be better. Wireframe gives you better views. This is the mesh, and that's what I want you to do during this week, guys. Okay?
We have a lot of work now.
Now, this is a standard mesh. What I have built here is a standard mesh. If someone struggles to build a mesh, I will give him this mesh next week. But in the meantime, rely on these photos you have taken and go. You have the geometry. Everybody has the geometry. Make sure it is correct.